So good morning. Again, we are continuing our discussion in the subject physics. The previous classes we have seen up to one type of electronics. The last topic is called digital electronics. In the digital electronics, we should know IC, the word everyone familiar IC. IC means integrated circuit. The integrated circuit is a digital electronics. In the integrated circuit, all the active and passive components are fabricated in the single chip of silicon. What is called silicon? You know, silicon is nothing but a sand, one type of sand. In the particular silicon, if all the active and passive components are fabricated in a single chip, it is called integrated circuit. What is the advantage of integrated circuit? We need not go for longer and lengthier circuit. Even a small chip, everything, amplification, oscillation, everything comes in a small chip. That is called digital electronics. In the IC, users is very important. IC is so cheaper, not costly, cheaper, highly reliable. The answer comes, we can accept highly reliable. Easy replacement. So simply we can change the IC by easy method. Whenever you are having advantage, there must be some disadvantages also there. IC, very important disadvantage, IC cannot repairable. But in our condition is concerned, anything is there, we have to repair it and then reuse it. Once it was like that, nowadays people make their mindset to throw it away. So ICs are like that, we cannot repair. If any problem in the IC, kindly remove the IC, we have to replace the IC by a new one. Then only it is possible. Otherwise it is not possible. That is important drawback. So in the IC, the operational amplifier is a triangle shaped ICs. In this there are 22 transistors, resistors, and the inductor will be there. The amplifier, operational amplifier, it functions the mathematical operation of integration, differentiation, addition, subtraction, everything. So that those amplifier is called operational amplifier. You might have did everything in your practicals. That is called addition, subtraction, like that. These are all the digital. In order to understand the latest digital, the logic gates, very important. The logic gates means we have to concentrate for logic gate by Boolean. So everything, if I ask question to you, if anything says, if you know your answer, you can say yes. Somebody may not know the answer, we can say no. If I ask one question, there must be two alternates, either yes or no. Like that. If anybody very height, tall, very small, short. Men, women, whatever may be the thing, the alternates are only two. So logically thinking. So logic, what is the logic in it? We are using the word usually logic. He is talking without any logic. He is always talking with logic. So logic means there must be some reliability. So just like that, logically the scientist thought like that. If any thing asked, only there are two alternate. If the switch is there, switch may be in the on position or in the off position, either on or off. Like that, anything you are having, you are having two alternates. Even the charge, plus charge and minus charge, like that. Anyhow, we are having only two alternates. But unfortunately, if anything asks you, come and say the numbers 1, 2, 3. So 1, 2, 3, 100, 1,000, 1 lakh, 1 crore, 10 crores, 1,000 crores, like that, endless it goes. The scientists thought logically, these numbers are also limited to 2, either 1 or 0. So all the numbers may be restricted to either 1 or 0. Since any numbers are restricted to these two numbers, either 1 or 0, are called binary numbers. Bi means 2. The numbers are called binary numbers. So we need not go for any other number. If any bulb in the off position means we can put the number for 0. If the bulb is in the on position, we can give the number 1. Like that. These are all called positive alternates. These are all called negative alternates. For negative alternate, we can put 0. For positive alternate, we can put 1. So these are all called binaries. These numbers are called binary numbers. And so many equations are also done by the scientists called Boolean equation. And they formulated the circuit for addition, multiplication, combination, everything. That is in the logic gate. The first operation for addition. So we want to add something. For addition, the first gate was introduced as OR gate, OR. Why it is a word OR is given? The symbol for OR gate, everyone knows. This type of gate always having two inputs, A and B. And it has only one output, C, as A plus B. So this is called OR gate. So any gate circuit, OR gate, AND gate, etc. will have two inputs and one output. This OR gate is used for addition. Two numbers as input, the output may be added. This circuit is called OR circuit. Why the name is OR is given? So here the Boolean table or truth table we have to understand. C is equal to A plus B. I already given the idea to you. If A is 1, B is 0. That means A gate is closed, B gate is open. 1 plus 0, 1. We are getting output. Or this gate is 0, this gate is 1. Here we are getting output. Or both the gates are closed, we are getting output. We never argued 1 plus 1 is equal to 2. 1 plus 1, here 1. Both the gates are in open, 0, 0. The output is also no output. So kindly measure this table. This table is called truth table. And the equation is called Boolean equation. Y is equal to A plus B. Output. Y is an output or C is an output. 1 plus 0, 1. 0 plus 1, 1. 1 plus 1, 1. 0 plus 0, 0. So, in order to get output, the output means we are getting 1. In order to get output 1, we should have either A as input or B as input or both inputs. So, in order to get output, we should have either A input or B input or both the input. Then only we are getting output. So, this circuit is called OR gate. How it is circuitally operated? It is connected to the battery. Here also gate A. Here also gate B. These are connected to a bulb and this connected like that. It is a lamp. This is gate A. This is gate B. What happened here? So suppose if gate A is closed, 1, B is open. What happened? The current may comes through A and the bulb will glow. The bulb will glow, answer is 1. This is the first truth table. The second one, the first A gate is open, B gate is closed. The current may be through B, again also bulb will glow. Both the gates are closed. A and B are closed, here also. Both the gates are open. What happened? So current may comes up to here, current may comes to up to here. It cannot go to the lamp. Therefore the circuit may not be completed. Therefore lamp will not glow. If it will not glow, the answer is 0. So this is the circuit explanation for OR gate. So OR gate is used for addition. Suppose multiplication. The gate circuit may be used to multiply something. That gate is called AND gate. A-N-D. AND gate. The AND gate, the symbol here also, it has two inputs, A and B. That is C equal to AB. The multiplication. We are getting the output. That is called AND gate. So two multiplication. This for AND gate. Here also truth table A, B, C is equal to AB. 1, 0. 1 into 0, 0. 0 into 1, 0. 0 into 0, 0. 1 into 1, 1. So in order to get the output, we should have the input A and B. Then only we are getting output. So it is called AND gate. Why it is called AND gate? In order to get the output, both A and B inputs are present. Then only we can able to get the output. That is the thing we have to understand it. How the logic operation? It's a very simple thing. The same battery connection is connected to the two gates. So here is a bulb like that, lamp. Gate A, B. If gate is closed, it is open. What happened? Current cannot go. So lamp is 0. So here also 0. Here also 1. Again 0. Both are gets open. No lamp. Both are gets closed. A and B gets closed. Then only we are getting output. These are all the explanation for what? The logic operation. So this is called AND gate. Similarly, we should understand about NOT gate. N-O-T. NOT. The NOT gate for inverse function. So the NOT gate has only one input. If input is A, the output is A bar. So logically we are having binary number 1. If input is 1, output is 0. If input is 0, output is 1. What are all the thing we are entering, that is called a NOT gate. The function of NOT gate to inverse. That is the thing. A become A bar. Similarly, AB enters in the NOT gate, they become AB bar. So we can combine in which way? For suppose the NOT gate combined with the OR gate. So they are called NOR gate, N-O-R. NOT gate combined with the OR gate is called NOR gate. We know OR gate having two inputs, only one output, that is called A plus B. That is A and B. So if this gate is connected to the NOT gate. So NOT gate has only one input, A plus B, and one output. It becomes A plus B bar. That is the thing. So in order to take a reverse function or inverse function, we have to use the value of NOR gate. For example, in the previous case, if it is 1, this is 0, the answer is 1. For here, the answer is 0. Like that, if it is 0, if it is 1, the answer is 1, here answer is 0. Both are 1, here answer is 1, answer is 0. Both are 0, there the answer is 0, here it is 1. That is reverse. So everything for a big chapter or big tabular column in which any Boolean equation may be verified by using this. This is called NOR gate. Another one is called NAND gate, N-A-N-D, NAND. The NAND gate is called universal gate. For example, if I get a gate circuit A and B. The output may be AB. This may be connected to the NOT gate. So it becomes AB bar. This gate is called a NAND gate. What does it mean? If both the gates A and B present, 1 and 1, there answer 1, here answer 0. All other cases we are getting 0, 0, 0, here we are getting 1 and 1. That is a inverse. Everything is reversed. We are getting the NOT gate. The NAND gate is called the universal gate. We are talking about it is a universal gate, so it may be useful for anything. So that we must be careful about the thing. Another also, sometimes the combination of gates are also there. If I take OR and the combination, what happens? We already discussed that OR is for addition, A plus B. Here AND is for multiplication, so we have to multiply. For example, if I get OR gate like that, A and B, the output is A plus B. So this is AND gate. I take one more input to C. So here we are having two inputs, A plus B and C. Here we are getting A plus B into C. So this is called OR and combination. In the OR and combination, first we can add the two numbers and add one more number to the AND gate. We are getting add and then multiplication. Similarly, AND OR combination is also there. AND OR combination. So first we are having the AND gate. In the AND gate, we are having two inputs, A and B. The output is AB. So this may be connected to the OR gate. So this is another two inputs, that is C. The output is AB plus C. What is the difference? Here first we have to add and then multiply. Here first then multiply and then add. So this associative law and also distribution law, everything we know. Commutative law, A plus B is equal to B plus A. That like that. These are the things we have to understand. The laws, everything can be verified by using these circuits. Those circuits are called gate circuit. This may be utilized in your computer and your calculators, everything we are having. That is in transistor also LED, light emitting diode. The energy emitted by the diode will give called light emitting diode. In most of the circuit, electronic circuits, we are having diode, and also the digital electronics, we are having the numbers by using LEDs. There are 8 LEDs, 1, 2, 3, 4, 5, 6, 7 LEDs are there. If all the 7 LEDs are in glow, that is called 7 segment display. If all LEDs are aglow, then it will number is 0 or 8. If it is these two LEDs are glow, 1, 2, 3, 4 and 5, this is number 2, this is number 1, this is number 4, this is number 5. Am I correct? This is number 6, this is number 7, like that. So in LEDs, we cannot put 2 like that. Here 2, 1, 2, 3, 4, 5 LEDs are glowed. Though these numbers are called digital numbers, you can understand it. So this is given in the table, OR gate, AND gate and NOT gate. So I have given in the circuit explanation here also. That is OR gate, AND gate. XRO gate is also there. A, B, XRO. So in order to get output, Q mean we are getting any one of the input is there. NOR gate, NAND gate, NOT gate. Everything we understand it. So that, and also we have to understand about the electronic devices. We know antenna. Antenna we know. Antenna, everyone knows, once it is called as aerial. In order to transmit the signal from one place to another place and also to receive the signals, we are using antenna. Skip distance, everything, where we are sending and where it is received. That is called antenna. Once 20 years back, in order to launch a single television, we have to set a very big antenna. The antenna, have you seen that antenna? Like that. Like that. Here there is a dipole will be there. So here also the line like that. The dipole means two equal and opposite charges separated by a small distance constitute a dipole. Here the wire connection is connected to the cable to the your television. What happened? Here the dipole LCR circuit. The signal response, if you tuned your frequency set in our receiver set, we are adjust the frequency. We are getting a particular frequency. Frequency current is maximum. Therefore, your radio or television response. These are all the things we have to understand in the previous classes. Radar, radio detection and ranging. Here we are using radio wave that may be sent and reflected from the object. By the velocity and the time taken, we can locate the distance. That is called radar. How the transmission and reception of radio and television. The transmission of radio very easy, only audio signal, whereas the transmission of television is very difficult because we have to transmit both audio and video wave, and also we have to receive both audio and video. But in order to receive both audio and video, what happened? We already discussed you that synchronize. So if in television, what happened? If anybody deliver a news, so simply we can read out and your picture also. So I am taking class, everyone receiving my voice as well as my picture. But we know the velocity of the picture very high, but the velocity of sound is very low. What happened here? That is an important thing as far as our electronics is called modulation. Modulation is an important thing. What is the modulation? The superimposition of audio frequency wave with the radio frequency wave is called modulation. The superimposition of audio frequency wave with the radio frequency wave is called modulation. Audio frequency wave and radio. That may be of three types. One is called amplitude modulation. Another is called FM, frequency modulation. Another one is called phase modulation, PM. PM is not comes in our India. AM and FM. So you are enjoying the AM, amplitude modulation, and also nowadays only the FM slowly developed. FM means frequency modulation. We are getting a clear output in the frequency modulation. But one of the important drawback is for FM, the frequency range must be around 100 only. Around 100 frequency only, we are getting the FM. Whereas amplitude modulation, the wide range of band will be there. The superposition of audio frequency and the radio frequency is called if the amplitude of the carrier wave. So in separately in radio, we are sending audio frequency wave. So naturally we are getting electromagnetic wave. The electromagnetic wave actually carries the audio frequency wave. But in television, we are creating both audio and video. This audio and video modulated and transmitted in the antenna. But our television system receives the signal both audio and video. So actually the radio frequency wave carries the audio frequency wave. So the radio frequency wave also called as carrier wave. So because it carries with a high speed, so that we are using for this transmission purpose. Everything we know, that is a modulation. Modulation, because if we want to go to long distance, we cannot go by walk. So we need some carrier. So we have to go by a car or bus. Bus actually carries you. That is called modulation. So as soon as you reach our destination, we least bother about the carrier and we have to impart it. Like that, as soon as your television receives the modulated signal, we need only audio frequency wave. The extraction of audio frequency wave from radio frequency wave is called demodulation or deduction. So you want to write a letter. So a letter cannot be posted. So the letter should be pasted inside the envelope. So the envelope carries your letter. If it reaches your friend or anything, the friend actually opens the cover and takes the letter alone and leave the envelope. Like that, as soon as you receive your destination, you have to extract the audio frequency wave from radio frequency wave. In television, the audio frequency wave, audio amplifier, and then fed into loudspeaker. And radio frequency wave in the radio frequency amplifier and fed into the picture tube. The picture tube gives your picture and your loudspeaker gives your voice. These are all the things you have to understand this. And also in computer, the Wi-Fi and all other connection, we are having modem. What is the purpose of modem? Modem is used to do both modulation and demodulation. If anything, digital pulse may be converted into analog pulse. So then only we are seeing your computer or anything. So that may be the instrument which is used to convert this is called modem. Fax. The real thing may be taken out. These are all the things for digital and the other things we have to understand it. So why I am saying these things very important for us. So in this electronic chapter we have seen so many items. Now we can pass on to some problems in electronics. And also in the frequency modulation, we know frequency 1 by 2 pi root of L into C. The first problem, the copper has FCC structure. What is FCC? Face-centered cubic structure with the lattice parameter 3.6 angstrom. Calculate its atomic radius and the density of copper, atomic weight of copper 6.35. So I am taking this type of repeated problem. I have seen so many question papers. Why I am giving that? In the chapter beginning itself, we have started directly not electronics. First we have started about the solids. In the solids, cubic crystal, simple cubic, body centered cubic and face centered cubic. I have given a chart. What is the value of atomic radius and what is the value of everything. I have given the thing. So kindly refer that the thing, the radius for FCC, face centered cubic, A by 2 root 2. I have given this formula for radius A by 2 root 2. So here, this problem, the value of A is given as 3.6 angstrom divided by 2 into root 2, 1.414. On simplification, this may be 1.273 angstrom. So this is the has FCC structure with the lattice parameter 3.68. Calculate its atomic radius. So you need not think it up, it is atomic radius. It may be atomic physics question. R is equal to R naught A power 1 by 3. You should not use that formula. That is radius, nuclear physics. Here FCC crystal. So for that we are having separate formula for that. But the density, the question is asked, that is also given in the formula Na divided by capital N into V. This also is given in the chart at the beginning of the class. That is equal to Na by N into volume AQ. So simply we are getting the value of A, that is for FCC, N is equal to 4. Copper has FCC structure with the lattice parameter. Calculate its atomic radius and density of copper. Copper has N is equal to 4 into 63.6.35 divided by N, Avogadro number 6.022 into 10 to the power of 26 into A just now we have calculated. A given in the problem 3.6 whole cube. On simplification, we are getting 9040 kilogram meter per minus 3. So I am choosing this formula. This problem means this 2 point. In order to calculate the radius, this problem is an example for FCC. The same question may be asked for BCC and also simple cubic. Simply substitute, we can able to find out the answer. The next problem, pure silicon has, this is a repeated problem one. This is also a repeated problem. Pure silicon has equal electron and hole concentration of 1.5 into 10 power 16 m power minus 3. Doping by indium increases the hole concentration to 4.5 into 10 power 12 m power minus 3. Calculate the electron concentration in the doped silicon. So many information here. I already given the information in the beginning of semiconductor itself. The semiconductor or electronics is nothing but the extension of electricity. In the electricity we are having a current. Whereas in the electronics we should have both electron current and hole current. So we have to concentrate IE and IH. Therefore, the sigma is also having sigma conductivity. Conductivity of semiconductor, we are having Ne mu E plus NH mu H. So Ne, that is called electron concentration, NH is called hole concentration, mu E electron mobility, mu H hole mobility. Everything I have detailedly given. So that I have given one formula also. The intrinsic semiconductor Ni squared is nothing but Ne into NH. I have given this formula. Calculate the electron concentration. The question is asked here. Therefore, Ne is asked. Ne is nothing but Ni squared divided by NH. What is Ni? Intrinsic semiconductor. Pure silicon has equal electron and hole concentration of 1.5. This is called pure. That is a intrinsic semiconductor. Therefore, 1.5 into 10 power 16 whole square divided by the whole concentration given in the problem 4.5 into 10 raised 22. So on simplification, this become 5 into 10 power 9 meter power minus 3. This is called hole concentration. This electron concentration is 5 into 10 power 9. So easily we can 1.5 by 5, that is 1 by 3. Everything we know, that is 10 power 32. If 10 power 32, if 22 goes minus 32, 10 power 10, that is 15. 15 by 4.5 into 10 power 9. 15 by 4.5, we know 5 into 10 power 9. Simply getting the values, we can able to find out. What is the importance of this problem? As far as the semiconductor is concerned, for N-type, electron is a majority carrier. Therefore, electron concentration is more than hole concentration in N-type. In the P-type, the majority carrier is hole. Therefore, hole concentration is more than that of electron concentration. The next problem, repeated problem. So once we know this, anything, if IC is given, the same problem may be called IE also. The current gain of a transistor in CE mode is 70. If the collector current is 8.8 milliampere and the collector current and the base current, find the collector current and the base current. There is a question. If a transistor in CE, the current gain of transistor in CE mode is 70. If the emitter current, otherwise you can change this IE. Emitter current is 8.8 milliampere. Find IC and IB, collector current and base current. Also find current gain of this resistor in CB mode. So in this, in CB mode, CE mode, the given is CB mode, CE mode. CE mode is current gain is beta, everyone knows. So output current by input current, IB. Because emitter current is F3. Therefore, what is the value of IC? IC value is beta times IB. So we can calculate the value of IC. So once we know beta and IB, substitute the value of IC. So in this problem, what is the collector current IC is equal to beta current gain is given as 70 IB. 70 into IB. We already know in the working of transistor by Kirchhoff's law, I is equal to IC plus IB. I is equal to IC plus IB. Therefore, IE is equal to IC 70 IB plus IB. Therefore, 71 IB. 71 IB is equal to IE. So 71 IB is equal to IE. Therefore, first I want to find out the value of IB. IB is equal to IE by 71. IE given as 8.8 by 71. Therefore, answer become 0.124 milliampere. So from which base current can be calculated because the emitter current is given. So once emitter current is given, we can able to current the base current, from which I can able to calculate the value of IC. IC also we can able to find out. How can you calculate IC? You can put 70 IB, 71 IB is equal to IE, from which IB can be calculated. Once we know IB, substituted here, IC is equal to IE minus IB, therefore 8.8 minus 0.124, that will give the value of IC. The another answer, also find the current gain of this resistor in CB mode. So CB mode, the current gain alpha, the relation between the alpha and beta by 1 plus beta. This is also derived in our introduction. Once we know beta, alpha can be calculated. Once we know alpha, beta can be calculated. Here beta value is given as 71. Beta value is given as 70 by 71. That may be 0.98. This is a current gain in CB mode, whereas current gain in CE mode is 70. So simply we have to mathematical manipulations. Finally substitute the values, we can get the answers. Last problem. A common emitter transistor amplifier has a current gain of 50. A common emitter. The common emitter means beta value is given. If the load resistance is 4 kilo ohm and the input resistance is 500 ohm, find the voltage gain of the amplifier. This is also very simple. We know the voltage gain is equal to current gain into load resistance by input resistance. That is equal to beta value is given as 50. If the load resistance is 4 kilo ohm, that is 4 into 10 cube divided by and the input resistance is 500. So this is a thing you have to understand it. That is 5 into 10 squared. 10 squared goes to the numerator. That is 10. This may be 10 into 100, 4 into 100, 400. So this is a voltage amplification is 400. What is this type of problem? What do you infer from this problem? There are so many aspects we are concentrating this problem. Once we know voltage amplification. So once we know the voltage amplification, we can have also current gain also we can calculate, or power gain. Sometimes the power gain is asked nothing but beta squared. If beta value is given into again 50, that will give the power gain. So this type of the thing we have to concentrate in the electronics. So we have to understand this type of problem, or very simple type of problem asked in the electronics. So kindly go through the definitions and other thing. Very simple problems may be asked in the electronics for your NEET examination is concerned. So thank you.